Okay, so we are going to continue here with topic number 13. And you can see by the graph that we've got here that we're just going to be moving it. It says to translate this graph, which the graph is a logarithm, we're going to translate it to become this. And the one big thing to remember with logarithm graphs is that when we talked about exponential graphs, we said, and it might not look like that, maybe it'll look something like this. Exponential graphs have asymptotes that run horizontal. So when we graphed those in a previous topic, we had a horizontal line going across. Now that we're doing logarithms have vertical asymptotes. So for example, this one, its asymptote is on the line x equals 0. And then I'm not going to show you this. You could type it in on Desmos if you wanted to find it, or you could type it in on your calculator. But the two things that are going to happen here is we're going to move to the left 4, because inside the parentheses it's a plus 4, and that moves it left and right, and we've got to do the opposite. So we're going to go left 4. So at this point right here, if I move left 4, 1, 2, 3, 4, and then I'm going to go down 2, because on the back side of this equation there's a minus 2, and we're going to do exactly what it says there. Down 2, so that would be, sorry, don't know what's going on here. Down 2 would be located right there. So basically you're going to take this point, you're going to move it over 4 and down 2, and then you're going to have a graph that is looking something like this. Okay, we're going to move on to the next topic now. So topic number 14. We're going to graph the logarithmic function g of x equals 2 minus log base 3 of x. To do this, we're going to plot 2 points on the graph, and then we're going to draw the asymptote. Well, this is a logarithm function again, so that means we're going to have a vertical asymptote. My vertical asymptote for this one, it's easiest if you just graph it on your calculator. You can see it really easily. My vertical asymptote on this one is going to be something like that. And then what you're going to do when you graph it is you're going to go to your analyze your graph function through the menu, and you can do the split screen table, and you can find some points. I don't remember exactly what the points are. I don't have them with me right now, and I don't have a calculator set up for this, but I know it looked something like this when we were done with it. So obviously the points aren't exact, but the graph would look something like that after you plot your 2 points. So you plot your 2 points wherever they're located and click that button. It'll make something that looks like what I have there. Then my domain and range, we need to talk about that for a second. When I'm talking about domain, that's all of the possible x values. Since we have a vertical asymptote that's on the y-axis, this means we'll never go negative with our x values. So it's going to be everything from 0, but not touching 0, so it's a parenthesis, to infinity. And then for my range, there is no limit for my range. This will go both to negative infinity and positive infinity. And the reason for that is we don't have any horizontal asymptote. It's going to look like, if you zoom out on Desmos, it's going to look like this perfectly flattens out and goes forever. It's just really hard to see that technically it is increasing over time and will not stop moving in the negative direction. There's no vertical asymptote there. Number 15, we're going to move on to logarithms now, and I'm going to show you something here quick. This right here is something that's super important to write down. We're going to use this basically for the rest of the video, these logarithm functions, and they're super important to have down. So I'm going to have you pause the video now and write these down. Sorry about this.
Just a reminder, there's a staff leader meeting in the little theater.
Sorry about the announcement, but like I said, make sure you pause, write this down, and then we'll move on to our topic.
That's a collaboration team leader meeting.
Okay, let's move on to topic number 15. So on topic number 15, we're going to fill in the missing values to make the equations true. The first one, I'm going to go over what you should have just written down there. Since there was a plus sign, this is actually going to be a multiplication question. Now, why this works is because if we have, like, for example, let's say b to the third power multiplied by b to the fourth power, if I asked you that question, you would say, hopefully, that the answer would be b to the seventh power. And so what we're really doing there is we're adding our two exponents in a multiplication problem. And the same thing is true here. Since we have addition, this is like a multiplication problem. So this would be actually log to the 70, or log base 8 of 77 would be your final answer, because I multiplied those two. So just like when we do exponents, when we multiply, we add, it's the same situation. Now with subtraction, it's division, obviously. So we had 5 there, so this would have to be a 7, so that when we subtract those, we get 5 over 7. Moving on to letter C. Log 6. This number out front is -2. So going back to, I can pull it up one more time here, the logarithm of a power, the big thing to notice is that P, I can't write on this, sorry. So P is now on the second part, it's in the front of that logarithm. So anytime you have a number in front, that could be placed as an exponent. So that's exactly what we're going to do here. This number in front could be placed as an exponent, like this. And then basically, what we're going to have to figure out here is, we don't know this, I'll call it x right now. X to the negative second power, because we moved that -2 to an exponent, is equal to 1 over 4. That's what we're trying to figure out. So this rewritten, and those two things need to be equal. And then we're just solving. So what to the negative second power makes 1/4? That answer would be a 2. X would equal 2. I've seen a lot of issues with this letter C. If you have questions with that, that would be something that you need to ask sooner than later. It's a very tricky topic. It's not super difficult once you get it figured out, but it is tricky until you figure it out. Topic 16. Use the properties of logs to expand this. So we're going to use those same properties that we learned on topic 15. Look back at topic 15 if you forgot what they were, or look back to your notes. But since this is division, I can separate it into a subtraction. So I'm going to go log x to the 5th minus log of y. And since we have an exponent there, I can actually move that 5 to the front. So then my final answer is going to be 5 times log x to the 5th. Oh, sorry, I already moved that 5. Minus log y. And that's all you need to do for that question. For the next one, we're going to use the properties of logarithms to expand this. It looks a little bit more daunting. Okay, so I'm going to take this, and I'm going to write my next step starting right here, since I've got a bunch of room down here. So let's see what we've got. I'm going to move this out of the way. So my next step would be to expand that, I think, a little bit. Actually, maybe even make that that cubed root into exponent form. So I'll have log of x, and then instead of doing x, the cubed root of x to the 4th, I'm going to put 4 over 3. We know how to convert exponents into fractions, so that'll be 4 over 3. Z is going to be 8 over 3, and y is going to be 1 over 3. Then I can expand this a little bit more, since those are all being multiplied. I'll go over here now. Log of x to the 4 over 3. I'm going to do plus log of z to the 8 over 3 plus log y to the 1/3. And then my last step would be to move all of those exponents to the front. So I'll have, and this will actually go in my final answer, but I'll have 4/3 log x plus 8/3 log z plus 1/3 log y. And that is the final answer. That's fully expanded. It's kind of a lot of work, but it's not too difficult if you know your rules from topic 15. Continuing with those rules that we discussed in topic 15 here, we're going to write this expression as a single logarithm, so we're going the other way, basically the opposite of what we just did on topic number 17. So let's change all these numbers in front into exponents. So I'll have log 7, not z, log 7 of z sorry, screen's kind of touchy, to the 1/3 power. And then we'll do plus log base 7, there I did it again, of y to the 3rd power minus log base 7 of w. And since there was no number in front of that log, I'm not going to make it an exponent. And then our next step, I think we can maybe make this our final step here, would be log base 7, right? That's what we want. And I'm going to need more room than just this, so I'll write it over here. Log base 7 of, well, we're going to have that z to the 1/3 power multiplied by y to the 3rd power. But then also, since this is a subtraction, we're going to have to divide. So I'm going to put all of that on top of w like this. So really what I did was I multiplied this piece with this piece and then divided by this piece because those two are added and that one's being subtracted. Topic number 19. Okay, so we're solving for x here. So the first thing I can do here is get rid of this 4 that's just out front. I'm going to subtract 4 from both sides. So we're left with log base 2 of x plus 4 equals 4. The next thing that I'm going to do is I'm going to change this into exponential form instead of logarithmic form. So that would be 2 to the 4th power equals x plus 4. And 2 to the 4th power is 16. So then that must mean if we subtract 4 from both sides, we get 12 equals x. It's always a good idea to plug that back in to see if it works, just to make sure, because I could see a potential where it might not work every time plugging it back in. Topic number 20. Now we've got multiple logarithms in this group, and these are natural logarithms, but we've got multiple in our problem. So to start, what I'm going to do is I'm going to try to combine them into one. So I see that there's an addition symbol here, so that means multiplication is my rule that I'm using. So ln of 2, and I'm going to multiply that by x minus 1. And then that's going to be equal to that negative 1 that's still over on that side. And then I can, distribute here. But at the same time, I'm going to go log base e of, I'm going to change it to that log base e first. And then if I want to multiply that 2 through, actually, I don't think that's really even necessary at this point. Let's just keep it the way that it is. Log base e of 2 times x minus 1 equals negative 1. And at this point, I think I can just change it to exponential form. So that's going to be e to the negative 1 power equals 2 times x minus 1. E to the negative 1 power is going to be some decimal. And it says don't do any intermediate computations and round to the nearest hundredth in the question. So that's what I'm going to do. If I type in e to the negative 1st power, or 1 divided by e, which is the same thing, that's going to give me 0.36 something. I've got it on my calculator. There's more to it than that. But that's going to be equal to 2 times x minus 1. And then I can divide both sides by 2. I'm going to move my work over here. So this would be 0.1839 something 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 equals x minus 1. And if I add 1 to both sides, that's pretty simple. We'll get, if I'm rounding to the nearest hundredth, we'll get x equal to 1.18 approximately. Topic number 21. I see we have logarithms on opposite sides on this question. So my first step is going to be to get them on the same side. That way I can combine them. So I'll leave the one where it's located. So my first step is just going to be to subtract all of this stuff over to the other side. I'm going to subtract it on this side as well. So I'm going to take this, I'm going to write it down on the bottom. So this will be logarithm base 5 of x minus 6. And then I subtracted that from both sides. So I'll subtract logarithm base 5 of x plus 2. And that's going to be equal to 1 because there's still that 1 on that side. If I subtract, that's the same thing as dividing. So I can do log base 5 of x minus 6 over x plus 2, just like this, equals 1. And now I can change forms. So I'm going to change it to 5 to the first power equals, which is, by the way, just 5, equals x minus 6 and x plus 2 over x plus 2. And this is something we should be able to solve from here. I know I'm just going to multiply by x plus 2 on both sides. So these are being multiplied, which means we'll have, I'm going to move my work over again here. So I'll have 5x plus 10 equals x minus 6, which is a two-step equation that you guys can solve. But I know that I get, when I solve, I get x equals negative 4. And this is one, I talked about this in an earlier problem, but this is one you definitely have to plug back into the original equation, because I think I did plug it back in, and I'm not sure that I got it to work. I think my calculator said it was not possible to solve. So I think this one would be a no solution, but I would just check to make sure. Topic number 22 says solve for x. By the way, so for this one, by the way, there's a new rule. Our rule is going to be anytime you have, for example, log base a of m equals log base a of n, and there's nothing else in the equation. It's just log base a is m and log base a is n. So basically, you've got the same bases. You can just basically say m equals n then. These two things are not necessary if they're exactly the same. So we're going to see that in this question. As you can see, you actually see it right away. So these ln's are log base e, but they can be canceled out. So we'll just be left with 5x plus 4 equals 5. And at this point, it's just solving for x. If I solve for x, I think I get x equals 1/5. And again, you should plug it back in to check, plug it in for, I guess, this x right there. But I think it does work. So topic number 23. Looking at this one, I think we want to change this to a logarithm. So if I change this to a logarithm, it'll be log base 16 of 64 equals negative x minus 2. And then log base 16 of 64 is something you could do on a calculator. I got like 1.5. And then now we're just solving for x, and I think you guys can do that. So if you solve for x, you should be able to get negative 3.5, I think, for your final answer, which again, you should plug in just to make sure. But yeah, I think that's the answer. Number 24. I'm going to change this one, I think, as well to a logarithm. So this will be log base 12 of 15 equals negative 2y. And if I do log base 12 of 15, it says round your answer to the nearest hundredth and no intermediate computations. I'm going to write down my intermediate computation just so you can see it, but I think I get 1.089799 something equals that negative 2y. And if I divide both sides by negative 2, I get y equals negative 0.54. That's rounded to the nearest hundredth. And that should be the answer there. Topic number 25. Okay, so with topic number 25, I'm also going to change this to logarithm form, but I'm noticing my base is e, so when I write log base e, I got to think to myself, okay, we're going to do natural log here, but I'll just write log base e for now of 7 equals y minus 5. Okay, and so I'm going to write this as ln of 7 equals y minus 5. Natural log of 7 is approximately 1.945910. That's equal to y minus 5. If I add 5 to both sides, that means y is going to equal approximately 6.95 rounded to the nearest hundredth. Just got a couple more here. 3 more, it looks like. Okay, so topic number 26. I'm going to do the same thing that I was doing on previous questions here. This was a long time ago where we were doing, my formula is y equals p1, times 1 plus or minus your rate to the t power. That's what you're going to use for this question. I know this is what it is because we're compounded annually. We have a principal, and yeah, it's the same type of question. So if I fill this out, we'll have, I guess you should read the question first. Maybe pause the video and read it so I don't have to read through it all. But I'm trying to reach this amount of money. So that's going to be what I'm trying to get to. It says my principal is this, and then my rate is, it's, by the way, this is increasing, so I'm going to do a plus sign. My rate is this, but I'm going to write it as a decimal. So that's 0.0575. And that's to the t power. Okay. Now I'm going to solve for t. And the first thing I should do here is divide both sides by 30,000. So 67,000 divided by 30,000, it's going to give you some decimal. I think it's somewhere around 2.23 repeating maybe, equals, well, I'm going to simplify what's in the parentheses as well. I'll put 1.0575 to the t power. And now we can make a logarithm out of this. So 1.0575, I guess that would be my base. I'm going to write it a little bit smaller. So log base 1.0575 of 2.23 repeating equals t. And if you type this into your calculator, you should get your final answer, which came out for me to be 13.08 rounded to the nearest hundredth. Nope, I didn't. Nope, that's not right. I got 15. It was actually almost exactly 15. No? Oh, yeah, no, it was, sorry. Oh, that's what I was getting confused with. It was saying it wants the smallest possible whole number. So I'm sorry. I guess t equals 15. When I typed it in, it was t equals 14.37 something. But we have to round up here because we're trying to figure out at what year we'll be at or above that 67,000. So at year 15, the start of year 15, you'll be above that 67,000. It seems like to me on these problems, I've looked through a few of them, it seems to me like you're always rounding up. I'd like you to prove it to me if there's a problem that you come across where you round down, but I'm pretty sure it's always rounding up. On topic 27, an initial amount of money is placed in an account at an interest rate of 1% per year compounded continuously. Whenever you see this word continuously, we've got to have a little bit of an alarm going off in our head. We're going to be doing something else. We're going to do a different formula for this. This formula is A equals P e to the r times t power. A lot of people call it PERT, and that's basically it. We're going to fill in what we know. So for A, actually, maybe there's one more thing I'm going to talk to you about. When we talk about r, when we talked about it in the past, it was usually subtracted or added to 1. This time we're not going to do that. It's just, for example, if it said you're going up 1%, we're just going to type in 0.01. If it says we're going down, for example, 6%, that would be like typing in actually a negative 0.06. That would be going down. So this is different than what we were doing in the past, but that's what we're going to be using for this question and the next question. So let's plug in what we know, I guess. It says our total amount, it says, was 1925.50. Our principal is what we're trying to find, so we don't know that. And then E, so I'll just put P there. And then E is just a number. And then R was 1%, so that would be that 0.01. That's going to get multiplied by time, which in this case they said was 4 years. So now we can just solve. All you have to do on this problem, honestly, is just divide both sides by e to the 0.01 times 4 power. So I'm going to divide that on this side too. If I can type this into my calculator, I should get the answer for P, because this stuff will cancel out with this. We'll just be left with P, and I get P equals 18.50, almost to the dollar. Even though it says round to the nearest cent, I think that's exactly what you get, because you get 0.00 something. Okay, topic number 28. The mass of a radioactive substance follows a continuous exponential decay model. So we're decaying here. We've talked about our rate before. So our rate for this one, since it's 5.3%, I'm going to change it to a negative 0.053. That's what I'm going to use for R when I do my PERT. So A equals P E R T. And let's plug in what we know. Well, first of all, we're trying to figure out the half-life. We're trying to figure out how long it takes for it to be half the size. So let's just plug in 1 for P, because it doesn't matter what we plug in for P. We want to know how long it'll take to be half. So if I plug in a 1 for P, my final amount that I want would be 1/2. And then I can plug in E. My rate I already figured out would be a negative 0.053. And then time is our variable that we're trying to find. So I'll put in T for time. And now we're going to solve. So the 1 here is not necessary to multiply this whole thing by 1. I might just erase it. So now it's just this. And then if I'm solving this, this is going to be a natural logarithm since our base will be e. So I'll go ln, so that's log base e of 1/2 equals it's negative 0.053 times t. Well, the logarithm of, or natural logarithm of 1/2 is negative 0.6931447, something like that. Trying not to round early here because it says don't round early, no intermediate computations. Equals negative 0.053t. If I divide both sides by that negative 0.053, you should end up getting 13.08 days. And it says what? Round your answer to the nearest hundredth. So that's what we did. And this should be your final answer for topic number 28.